So, good evening. I am Raj Sharma and I am here to present my paper, which is Design and Analysis of Vertical Axis Wind Turbine using CFD analysis. So, this is the introduction. What is a vertical axis wind turbine? Vertical axis wind turbine is a type of wind turbine where the main rotor shaft is positioned vertically perpendicular to the ground. The performance of the VAWT is influenced by various design choices and external forces such as wind speed and turbulence. Analyzing the performance of VAWT involves simulating its performance under various conditions and calculating its power output. There are several analytic methods and computer simulation that can be used, including computational fluid dynamic simulation, blade element momentum theory, and experiment testing. We use computation fluid dynamics for analyzing of wind turbine and design of what we use SolidWorks. By considering various design choices and simulation performance under under wind condition, researchers can optimize what design to generate more energy to contribute more sustainable future. And here is some literature review which we had taken for our research, and what is the objective of this paper or this project. So the main objective of this research is following. First, the maximizing the turbine efficiency. So the design and analysis of what should aim to maximize the amount of wind energy that can be converted into electrical energy. This involves optimizing the shape, size, and configuration of turbine blades as well as turbine overall design. Second, ensuring the turbine structural integrity. The watt should be designed to withstand the forces and stresses that it will be subjected to during operation, such as wind loads and vibration. This involves analyzing the materials and construction method used in turbine design and ensuring that they are strong enough to withstand these forces. Third, minimizing the turbine environmental impact. The design of this analysis of vertical axis wind turbine should be take into account its potential environment impacts such as noise pollution or bird strike. This involves the designing the turbine to minimize this effect through measures such a new noise reduction material or bird friendly design. Fourth, achieving a cost-effective design. Finally, the design and analysis of vertical axis wind turbine should aim to create a turbine that is cost effective to manipulate, install, and maintain. This involves considering factors such as material cost, constructional complexity, and maintenance requirement in order to create a design in both efficient and economical. So what is the problem statement? The problem statement for this design and analysis of vertical axis wind turbine is to address the growing demand for renewable source of energy by creating a turbine that can efficiently and sustainably capture wind energy and convert it into electrical energy. This involves designing a turbine that is structurally sound, environmentally responsible, and cost effective while also optimizing its efficiency and performance. Additionally, the design must take into account the site specific with condition and any regulatory requirement and address potential issues such as noise pollution or bird strike. Overall, the goal is to create a vertical axis wind turbine that can successfully deploy and provide a reliable source of renewable energy. So, what is the design? So, this is the design of the vertical axis wind turbine by CAD model of vertical axis wind turbine using SolidWorks. SolidWorks is basically a software which is used to design this. And this is the simulation which is of meshing. So this is the meshing simulation of the vertical axis wind turbine with the given data. So this is the simulation. This is the domain interface. That is the inlet. That is outlet C, and that is interface, and that is interface number 2. So this is the boundary condition, step by step boundary condition. This is the result. This is the result of velocity using CFX, and that is the simulation pressure using CFX. This is the function calculator which we have taken for the simulation. So what is the conclusion of this paper? So basically the conclusion is that small scale wind turbine blades may be construction from wood, making it possible to imagine building a cost-effective wind turbine using standard workshop equipment. The most power can be generated from vertical axis wind turbine with the most blade. But a low solidity wind turbine may have trouble getting going on its due to rotor efficiency at low tip speed. For any value of ambient wind speed, there exists an optimal rotating speed for the turbine at which maximum efficiency is reached. Energy output for fixed pitch with turbine may be optimized by matching the rated airspeed to the typical wind speed at the site installation. And when operating at the same speed, turbine with larger radii are more efficient than those with similar radii because the greater tangential velocity result in lower angle of attack, larger Reynolds number, and therefore larger lift coefficient for the blades. So thank you. These are the references.